So, we shall continue with our next session. Now we're diving into clean, cost-effective energy solutions with Milan Bradonjic, a senior software engineer at Schneider Electric. He's here to shed light on how artificial intelligence is revolutionizing solar power for the better. Milan brings a wealth of experience from prestigious institutions like Los Alamos National Laboratory and Bell Labs. His focus on using AI tools, image processing, intelligent matching, and automated guidance promises to make solar power more accessible and affordable for everyone. Milan will unveil how AI is reshaping our path to sustainable, renewable energy. It's a glimpse into a future where clean energy is within reach for all. The title of his talk is Using AI for Cheaper and More Efficient Solar Power. Mr. Bradonjic, the floor is yours.
Evo, hello. Thank you.
Start.
Cool. Okay. There is microphone, yeah. I'll do it quickly. Do not worry. Ajde, ne, nisam te čuo. Da, samo sekund. Hey, just a second. Can you? All right. Okay. Ajde, možda ti bolje sa tvojom opremom. Sure. Okay. Yeah. We have plenty of time. The coffee break is after that. Thank you for introduction. It wasn't. Don't laugh. Sure. Yeah, I think the presentation of myself should have been better if it was now rather than when it was plenty of people moving around, but I can give you the flash with the slides if you want, if it's easier. If it's not getting the signal there. Slides. Nema. Aj, Bela.
Jesi on snima? Okay, sure.
No. Hey, I have a solution for the technical support. Flash. Maybe your cables do not work, but I have a solution. No problem, we can start. Yeah, right. Sure.
Okay. Thank you for your patience. I shall repeat this because we need to record this for the video. Okay, now we're diving into the world of clean, cost-effective energy solutions with Milan Bradonjic, senior software engineer at Schneider Electric. He's here to shed light on how artificial intelligence is revolutionizing solar power for the better. Milan brings a wealth of experience from prestigious institutions like Los Alamos National Laboratory and Bell Labs. His focus on using AI tools, image processing, intelligent matching, and automated guidance promises to make solar power more accessible and affordable for everyone. Milan will unveil how AI is reshaping our path to sustainable, renewable energy. It's a glimpse into a future where clean energy is within reach for all. The title of his talk is Using AI for Cheaper and More Efficient Solar Power. Mr. Bradonjic, the floor is yours.
Thanks so much. Thank you. All right. Clicker. Is it working? Ah, wow. Thank you so much. All right. Am I too loud or not? All right. Thank you very much for being here, for the invitation. Super happy to be here. Okay, let's start. So, what's the motivation? Renewable energy, meaning the energy derived from the natural sources, are practically solar. Actually, particularly solar power are vital for sustainable and resilient energy. So we've seen significance of renewable energy. So first of all, we definitely are facing transformation of the traditional energy to something more sustainable. Secondly, we should be concerned, or at least we should be considered about gas emission, mitigate climate change, promoting energy security, meaning that we should be able to get the energy. And secondly, there is a note of these artificial intelligence optimizing all these processes with all of this. All right, so these pictures are just to give you the idea how the solar power stations on the left and individual rooftop panels look like. They are taken from the wiki. Why voltaic, which means that the solar energy is transformed into volts, meaning into electrical energy. And apparently, if you search on the net, you can see that there are, actually you can see even the energy sizes of these farms. The majors are in China, India, Emirates, etc. Okay, this slide is kind of very educational. Educational, which means that I just want to show you what's happening actually on the user level. Say that you have solar panels on your rooftop, which are receiving the solar energy. You're obtaining the direct current transformed into analog current, which then you're using for your devices, maybe even store, and even though going to getting the energy back to the grid. This arrow is not bidirectional, but for every systems, but it's from Wikipedia. Okay, any questions so far? Quick question. I think it should be relatively easy. All this on Wikipedia. Okay, so yeah, easy to make, right? Okay, so what are the potentials of the solar power? Definitely prominent and abundant renewable energy source. Potential is vast. Supposedly that sun is consistent and it can be reaching any place on the planet, and it has a capacity to meet a significant portion of the global electricity demand. Why am I saying this? Because in the US, the current solar power being used is under 5% of the total capacity. Okay, where is the AI getting into the game? Definitely there is predictive analytics that you want to play with, like analyzing historical and real-time data, weather patterns, energy consumption predictions. Smart grids, you want to come up with adaptive grid. Maintenance, reduce the downtime time, and energy management, really to make up some predictions on the consumption as well as the demands in your electrical grid. Okay, we Energy Sage, as a part of Schneider Electric, have a couple of goals. The A goal is to empower people to switch to affordable, reliable, clean energy with the trusted resources. That's kind of important. And secondly, what we do is build tools like image processing, clever matchings, and also automated advising, so to reach financial as well, so that you can reach financial and environmental benefits on your local solar level. And this is presented in this picture. You have it, the goal of the company. Okay, so all right. So now what's the main, this very nice all and kind of intuitive, but what are the real problems? Let's say you want to build up this product, right? And if you wanted manually to identify suitable rooftops and to replace those, you can be facing many challenges. First of all, it's time consuming, labor intensive, you have to send a crew. Secondly, do you have enough people to send to different locations? It's of course cost and resource constraint. Secondly, it's extremely subjective because it's manual work. You can see many data inconsistency. It's very complex. Secondly, actually, lastly, you might have very regulatory appliance issues, etc. Okay? So, in order to do so, what was the originally started? Actually, the idea was to let's abridge this problem. Let's start machines doing something for us, actually building up the product, and that's really what is very hard in what you know in the industry, building up the product and everything infrastructure around the product is the following. So instead of doing all of these, myself calling, hey, can you come and evaluate how many cells I need, how much I have to pay. Ideally, I would like to pin a point on my rooftop and say, this is my location, I have certain target, just provide me with all out quotes, what I need to pay, how many panels I need, etc., so that I attain a certain target, annual target. And your answer more or less should be like this. Okay, you will need this many these objects, your your expected max yearly production would be the following, your total yearly production would be the following, and given that your target production is some nominal unit that you asked. And of course, this is how your panels, these arrays, actually the blue ones, would be placed. I'm just giving you some, how to say, to get the idea how the process looks like and the idea of sorry, I might be having some echo stuff, maybe not. All right. All right, so in the essence of this, or maybe it should be going down a bit, sorry, thank you. Very good. So in the essence of this question, there is the algorithmic part, just to show you, which is based on the following. Programmatically is in a couple of blocks for a given input, which is your orthophoto from the aerial photo, Google image, satellite image, etc., or even maybe from a drone or some that you might be buying. You have a couple of blocks, and now it's really interesting part, algorithmically at least. You have a first block, which is kind of rotating the image and really then finding the alignment, the line of your position of your object, say a roof, meaning the house or the building, a building. There is a segmentation part. I explain these details in details later on. Segmentation that you find those blocks. There is certain post-processing, say solar power estimates, I will say, and then finally you place your panels. Essentially is this. Okay, so now let me tell you a little bit about each of these blocks, if you are interested, of course. On the at least I am, right? Okay, so given that I said these rotation and segmentation parts are two neural networks, actually depends, three, right? Depends how you look at that. So it's based on data. So we get, say, order of 100,000 images which are manually marked, so it's labor is involved in these. You marked your rooftops, trees, obstacles, contours of the buildings. What are the obstacles? Something like chimneys or the parts of your rooftops over which you can't post your panels, etc. You have to avoid these parts of a rooftop. Okay? So that's that part which you can't avoid because there is no source that you can just pull up that somebody did it for, it already exists. Secondly, what I said, these two blocks, there are two neural networks. RotNet, which is practically deciding upon where the alignment, actually the line, the position of your, comparing north-south, east-west, where your building is. And secondly, the second part is the segmentation part, which recognize these segments that I told you, facets. I'll show you what facets are, but probably you can imagine obstacles, shadows, etc. So really, to tell you, this is really the real debugging part, how it looks like. For example, these red covered blocks are the facets. And what's interesting is that you usually don't have, not usually, but actually often, you can be facing that rooftops are really not two plain rooftops, but something very complicated, which is even not perpendicular, etc. So you have to identify those. These yellow stuff would be, the obstacles, chimneys, or something else. I marked the coordinates of the house, and this is really from production, from actually debugging part that you're getting. And so what you can imagine, secondly, shadows, what I said, and it's very, if you have an object, say a tree, okay, depending on the time of a day, and your image will not be or will be showing a shadow. The shadow will be moving, right? So it's really, when I say shadow, it's not that you are identifying a darker area in the image, but actually finding there is algorithmic part which is estimating the area of your building which will be covered during a day by shadow. All right, and of course it is not necessarily set in stone. Maybe somebody will cut the tree, maybe that part of the other building will be moved, etc. So it's really, a complicated business. All right, so when I say segments, I mean on these little, for example, these facets marked by like red polygons. So there are kind of nine facets or places on the roof, say one flat, and secondly, your facets or your planes can be under a slope, under certain slope faced. So how we measure, actually how we mark them, according to the azimuth position, say to the sun, and the angular distance in the XY plane, azimuth, and the mark is one of the 8 possibilities, north-northwest up to south-northeast, pardon me. You have a contour of the building, you have the obstacles, what you mentioned, and shadows. So there are a couple of segments to be formed, okay? All right, Right, yeah. Cool. Training took about, so if you train on about 500 epochs on this particular machine, 100K images, it takes about 18 hours. So if you took, so that's what it is. Post-processing, if you ever done this, you're probably familiar. Once you identify the segments, always the question is, hey, are these contours really right? Which one should be joined? Which one should be separated? Do you have to fill the holes if you ever dealt with these computer vision problems? Each of these, and now you can ask standard, I mean the set of steps. For a certain thresholds, you have to identify which of these contours are really valid or not, which you want to exclude or include. So there is a little bit of post-processing here, programmatic post-processing. And in the end, which is also very, how to say, both interesting and a little bit challenging task, I'll explain why. In the end, you are getting the, say, two image, the ground truth image and the labeled image by this algorithm, and have to decide about the, about the accuracy, okay? So the question is, okay, fine, I do have the labels. I have the labels, right? But how am I certain that my labels are really right, and why? So for example, these labels, what I said, are manually done. In the end of the day, the guys who labeled, you know, it might be a mistake whether it's a little mistake. How do I know whether it's really a shadow or an obstacle, whether it's chimney or something else? So there is a little bit of this 0.04, meaning 4% estimated manual error in the entire process of the labeling. So say the accuracy is about 90% plus minus 4. Okay? So not that bad. In fact, very good. In fact. Because what I said, it's a lot of manual process, and you can easily be, you can be wrong. So given all of these, right, so I told you kind of, you have identified the objects, and in the end of the day, you want to ask, fine, I have my object, I have my, all right, I have my object, I know where I can place my, say, panels, etc., but how much energy can I really produce? So we do use their services which do that. We do use the PV Watt service by National Renewable Energy Lab, US. So for example, how it looks like, I just took a couple of screenshots. So say you input concretely here is the zip code 10012, Lower Manhattan. It kind of showed the radius 0.9 miles, 1.3 kilometers, whatever. And it can give you the specification if you posted a panel in a given place, it will give you a specification how much energy you can be getting. How do they know? Because they're constantly be tracking solar radiation, and according to that, it's more or less linear, you know, the energy that can be produced. So these numbers are really tracked over time. You do use that service, and according to your latitude, longitude, on average, because I don't know whether I'm covered by some other area or something like that, I can estimate the production, my early production. Okay. So this looks kind of interesting, challenging, etc., but we are facing because many current and future challenges. So one of what I said, building a product and putting into real world. So for example, it's not quite clear. It's not quite clear if I am, say, a customer, potential customer, and say, oh, okay, can I get the quotes? Whom should I be dealing with? Whom am I going to make a deal with the installer. Somebody who is the closest, the higher ratings, etc. But it's really not clear whether our customers want to say a best solution or more than 10 or all of them or something like this. It's not clear, and it's very, very, how to say, personalized. Do I want to see a best solution, not to think anymore, or I'm a person who would like to read absolutely all possibilities and to decide upon that myself? Secondly, which is really current, and we've done some work. You have a web page, you have a knowledge contained in that, and people want to be more engaged into this. If they seek for information, they want to do in a progressive manner. We have done some embeddings of our knowledge and train certain models so that you can make these you can learn about the product and everything else in a more progressive manner. Right? Definitely one of the biggest things that I always worked on is the conversion, or actually the retention rate. So the question is, how many of your customers, or what is the percentage that your customer will get on a platform? So for that, you can use text and speech analysis. There is some work, and it's practically the part of the future work. And one thing that we would like to attain, 10 seconds, to come up with a unified product where both shoppers, manufacturers, and products would be in one unique marketplace, so that you can combine different green energy, both for rooftop and storage, heat pumps, community solar markets. Yeah, thank you so much. Thank you, everybody. Hope you enjoyed the conference. And